on looking at significant digits when it comes to pH and pOH, and just so we make sure we don't get this wrong, because it is pretty easy. So first, just remember regular sig-dig rules. If you have a 0 between two numbers, so any number other than 0 is significant. If it's in between two numbers, it's significant. So this one has 3 significant digits. Zeros that are trailing are significant. So our next number, 3.0, has 2 sig-digs. And zeros that are in front of a number are not significant. So the number 0.34 has 2 significant digits. So this 0 does not count. So that is if we have any value that's not pH or pOH. But if we have pH or pOH, it's a little bit different. And for this, you only count the digits after the decimal. So the only significant digits that matter are the ones after the decimal. Any number before does not matter. So if you have the pH of 3.04, 2 places after the decimal, this has 2 sig-digs. pOH has the number 4. This has 0 significant digits because there's no number after a decimal, where 4.0 has 1 significant digit because we have 1 digit after the decimal. So we just want to remember that with pH and pOH. And then I do have just a few examples here. If you want to find the pH of an acid with the concentration for hydronium of 0.0501, so we first want to look at this and realize that there are 3 significant digits. And you might hear significant figures instead, but same idea. So these 2 digits are not significant. The following 3 are. So what we're going to do is calculate the pH, and the pH equals the negative log of the hydronium concentration, which we have. So we'll just write that down and we'll plug it into our calculator. So I'm just about to do that. I want to do negative log. Sorry, I should have had this written down already. 0.051. Oh, not 5101. And I get this value 1.30016, and it keeps going. So when I want to follow 3 significant digits, I would count the 3 after the decimal. The 1 beside this last value does not affect my value, so I could just drop the rest. So we have 1.300. Now, if this was, say, a diploma question and you go to fill in the boxes and you only wrote 1.3, you could get it wrong, because even though you did everything right, you're not answering with the correct significant figures. So just another example, just looking at the concentration of the hydroxide ion. If you're with hydroxide, you're dealing with a base, not an acid. So you'd want to take the pH first and subtract it from 14, so that you are dealing with the pOH, so a base. So 14 minus 12.12, we get 1.88. And then if you want the hydroxide ion, then we'd have to remember that the hydroxide concentration is 10 to the negative pOH. And that's what we calculated here. So we'll do that 10, and then we'll do 10, raise it to the power of negative 1.88. And we're getting the concentration to equal 0.01318, and this number keeps going. So then going back to our original question, looking at this pH that's given, right, with significant digits, this has 2 significant digits. So coming to our concentration, if we want to keep 2 significant digits, we're following those rules, keeping the 2, just your normal rules, not the digits after the decimal. So the 1 beside the 3 does not affect it. We can drop the rest. This is going to be 0.013 moles per liter, and that is showing 2 significant digits. So as always, I hope you found this helpful. If you did, please subscribe. I do have a website that's not showing up right now, but if you are in chemistry, then please follow my channel and take a look at my website, where it does list the unit and then every lesson with homework and practice tests at the end. So I have one for thermal, one for electro, equilibrium acids and bases, and organic. I hope you found this helpful. If there's any other video I can ever do, just leave me a comment, and thank you for watching.